Nope, because you can't. Yeah, you're gonna have to use the product and chain rule. That's correct, but you can't simplify. You can't isolate y. Do you agree that it would be really, really, really hard to isolate y in this equation? Yes. It's probably not. It's almost certainly not a function. So really challenging here. Really, really challenging to isolate y. So you have to use what method of differentiation are we using? Implicit time. Implicit differentiation. So let's do it. If you're implicitly differentiating, what's the derivative going to be of y to the fifth? Correct. Plus, and then what do you have to use to differentiate this? What rule? You're going to have to use the product rule right here. What's the derivative of the first? Times the second plus the first times what's the derivative of y cubed? Yep. You just used the product rule right here, and it turned into that. And you have to do it to both sides. What's the derivative of 1? 0. And what are you going to have to use right here? The product rule again. Yeah, that's right. What's the derivative of y? Yeah, the derivative of y is just going to be y prime times e to the x squared plus the first times the derivative of the second. What's the derivative of e to the x squared, Biggie? E to the derivative of e to the x squared. What is it?
E to the x squared times 2x.
Correct. You just differentiated. It's not. It's asking you to do one more thing. What do you now have to do? You're not done. You haven't. Yeah, you have to solve for y prime. Where are the y primes? There's 3 of them, right? So what's our so now what are we doing? We're isolate y prime. That's what we're doing next. So if we want to isolate y prime, how do we do that? Yeah, now it's just algebra, that ninja thing I told you about. Now it's, did I tell you about that acronym? And now it's just algebra at this point. You put everything with y on one side and you isolate everything with y prime on one side, you factor it out and you divide. Do you need me to do that?
No.
Okay. Now it's just algebra. Now isolate y prime, then done. Okay, what's another one, people? So it's secant squared. Are you sure?
Yeah.
Okay. Secant squared xy, but then we have to multiply by the derivative of the inside. What rule are we using here? We're differentiating implicitly, but we're going to need to use the chain rule. What's the derivative of x minus y? 1 minus y prime equals. Now we take the derivative of the right. Looking at that right there, what rule are we going to have to use, do you think? The quotient rule. How can we avoid using the quotient rule? What's another way to write that? It's another way to avoid it. I like, in general, it's not always the best thing to do this right here. But instead, what overall rule can we use now? The product rule. The derivative of the first times the second plus the first times the derivative. What's the derivative of 1 plus x squared to the negative 1? Negative 1 plus x squared to the negative times 2x. And now it's just algebra. You're isolating y prime. The y primes. One of them, so you have to distribute y prime right there. Any others? I think it's just 2 of them. So you have to distribute and do some algebra, but it's just algebra at this point. That's it. You've implicitly differentiated, and inside your implicit differentiation, you have used the chain rule and the quotient rule. Slope is 0. Horizontal tangent slope is 0. So what specifically has to be 0? So if you found a point, how do you test to see if the tangent line is horizontal? The derivative is 0. So you want to find where what is 0? Where y prime is equal to 0. So to find where y prime is equal to 0, what do we need to find first? Y prime. 6y squared y prime plus 2y prime minus 5y, it's the fourth y prime, is equal to 4x cubed minus 6x squared plus, what do we factor out of all the terms on the left? Yep.
So we use chain rule when y is to a certain power, but when it's just y, we use the product rule.
No.
Or is that the product rule?
We use, on every single one of these right here, we use the power rule, but inside the power rule, we use the chain rule, because instead of, we're actually using the chain rule every single time, but what's the derivative of x? 1. What's the derivative of y? Y prime, because we're taking the derivative with respect to x. So in this case, we're actually using the chain rule every single time here. What's the invisible number being multiplied by all three of those terms? 1. The invisible number being multiplied on the right is 1. Do we write that in? No. So what do we factor out on the left right now? Y prime. So you end up with y prime is equal to 4x cubed minus 6x squared plus 2x over what? 6y squared plus 2y minus 5y to the fourth. You want to know when that is equal to 0. How many people got to here? You want to know when that's equal to 0. How do you solve? When is a fraction equal to 0? When the numerator is 0. Do you really care about the denominator? As long as the denominator isn't 0, it doesn't matter what it is, right? What do you factor out? Ah, better. I like that. Factor out 2x, and you end up with 2x squared minus 3x plus what? 1 equals 0. Can you tell me one of the solutions? X definitely equals. That's one of the solutions, right. But now you need to see if what factors. Ah, that thing. Does it factor nicely? 2x what? And x minus 1. So what are the solutions? 0, 1/2, or 1. So how many places have a horizontal tangent line? At how many points? 3. What are the x values? There. Now, why don't they ask you for the points themselves? Like, they're doing you a favor. They're not asking you for the points, which would be an x and a y coordinate. They're asking you for just the x values.
Because there would be multiple points at each of them.
Possibly, yeah. And also, possibly, but just what do you do? If you have the x values, how do you find the y values? You substitute x back in. Does that seem like a lot of fun?
No.
This is a gift. This is a gift saying, don't worry about it. You don't have to find the really ridiculous y value. The other thing is, even if you plugged in the x values right there, do you have any, let's look at the original equation here. If you plugged in the x values, do you have any way to solve for the y values?
No.
What would you have to use? You'd have to use your graphing calculator. Think about this. This, when you plug in x in there, you'll get a constant, right? You have a constant equals something to the 5th power. Well, actually, you could maybe if you factored it, but is it going to be a nice process? No. So to answer this question, there are 3 points. The x values are 0, 1/2, and 1.
If you put 0 into the equation,